Okay, we're going to look at a cycloid. So a cycloid is the curve that is traced by the path of one point that is on a circle as the wheel rolls. And here's, there we go. Here's a picture of it. Okay, so you can see that that point as the wheel is rolling is making these like two humps. Okay, well, I mean, it'll keep going forever, but yeah, so that's what a cycloid is. Okay, and we're going to go through and we're going to look at we're going to write parametric equations for the path of a cycloid. Okay, so to do that, we've got to label some stuff, and I'm going to start with this right here being the starting point. So this is my y-axis. Okay, this is x-axis. And the radius of the circle, we're going to call that A. So radius is going to be A. So that's this length right here, and it's a circle. So that radius is always A. Okay. And then let's see. So we've got a height here of y equals A, and then the height up here is going to be 2A because that's the diameter. Okay. T is going to represent the angle of rotation. And I'm going to do some more labeling on here. So give me a second to make sure I label all of this. So this is horizontal. That is not up at the top. That's just at the height of where this point is. We'll call that point XY. So XY is moving. And then we have this vertical segment right here. Again, this height is A because that's the radius. Then I'm going to label the center as C. This point is going to be N. M is going to be the x coordinate of point P, just so I can name the point. R is going to be this corner of the triangle right here, and that is a right angle. Okay, and then T, the angle of rotation, is this angle right here. Okay, and actually I can make this a little bit bigger since we're only looking at that one. And so it's the angle of rotation of this segment right here, that radius. So it's the angle of rotation technically of segment CP, or the radius CP. Okay, and then let's see, because this is a radius, we also know that this has a length of A. Okay, so then what we want to do is write a parametric function because we're going to write one function to express the x coordinate of this point and another point to at some value t, and then another point to write the y value of t. Okay, so O(n), oh, forgot the origin. Origin's O. Okay, so O(n) is going to be the total arc length, or in other words, the total amount of that the circle has rolled, or that the wheel has rolled, if that makes sense. So let me write that in words. So this is the total arc length. And arc length we know to be S equals r theta, okay? Arc length is radius times the angle. So the radius is A and the angle of rotation is T. Okay? And then, so that's the total amount that we have rolled. So think of it as like, as this rolls, you know, the point, the circle kind of flattens out. And then R, oops, R C is this length right here, and we're going to use a trig function right here to just using with SOHCAHTOA right there. So that's going to be A times cosine of, and then this angle right here is half of a circle, so pi minus the angle of rotation. So A times cosine of pi minus t. Okay? Now, because cosine is an even function, we can actually use a little substitution here, and we can write that as a times negative cosine of t, okay? So we're just using the fact that cosine is even here in that identity. You can move that negative to the front. I'll do that on a later step, I believe. Yeah, we'll move that to the front on the next step, okay? All right, so now for x, we know that x, the x function, or the horizontal distance here, is the length OM, okay? And so that's going to be equal to ON minus, so it's going to be the total arc length that has traveled by this point, minus this distance right here, PR. PR, okay? And then ON we wrote up here is AT, and then PR is this horizontal distance. Using SOHCAHTOA again, we can write that as A times sine of t, okay? That horizontal distance right there. Oh, actually, one second. PR is A of sine of pi minus t, to show you where that came from. And since sine is an odd function, this is the same thing as a sine t. Okay, so we've got AT minus a sine of t, or if we factor out the a, we can write this as a times t minus sine t. Okay, so this is our function for x, or x of t, or f of t if you want to write it like that. Okay, and then for y, the parametric function representing the vertical change, y is the same height as what we would label here as Pm, okay? And that's going to be equal to this radius, which is Cn plus the height here, which is Cr, so Cn plus Cr. Cn radius is A, and we're going to add that to CR, which is this height right here, which, oh, I labeled it RC over here. Okay, which we just found up here to be negative A cosine t. I'm going to factor an A out of that, and so we get 1 minus A times 1 minus cosine t. So this is our function for, or the part of the parametric function for y, okay? So these two equations represent the path traveled by a cycloid, and we can specify where A is the radius, okay? You do not have to have these memorized, but when they come up, you do need to be able to go back and look at those equations.